Hi, this is Arjan. In today's video, we're going to talk about variables and types in C# programs. When you write a program and you want to use memory in some way, the only way to access this memory in a program is by using variables. And variables have a type, and the type basically states what kind of information you can store in that variable. Let's look at a very simple example. So if you want to use variables, you first need to declare them. And declaring basically means telling a compiler that you're going to use a piece of memory. So here is an example of a variable declaration. As you can see, it consists of two parts. The first part is the type of the variable that indicates what kind of memory you're going to be using. In this case, the type is int, which is short for integer. So it's an integer number that we're going to store. We also need a name, because if you're going to refer to this information, to this piece of memory, you need a name in order to refer to it. So let's call it test for now. If you want to, you can make multiple declarations of variables. Yeah, so for example, if in a game you need to store the number of lives that the player has, as well as the player's score, you can simply declare two variables like this. Of course, if you want to and you think it's clearer, you can also do it like this. You can declare as many variables as you like in a C# program. But when you compile the program and you don't use the variables that you declare, the compiler will warn you about it. Yeah. So once you've declared these variables, you can also assign them a value. For example, let's give the player 5 lives. As you can see, in an assignment, you use the equal sign. Now you can also combine a declaration and an assignment into a single instruction. Here's how you do that. And of course, let's start off with a score of 0 for the player. And again, if you want to, you can actually make these declarations and coupled assignments in a single instructions, like so. You can't just choose any name. You have to worry about the characters that you're going to use in a variable name. For example, it's not allowed to start a variable with a number like this. It has to start with a letter, or you can start it with an underscore, or if you want to, you could even start a variable name with an @ sign, and that's basically it. You're allowed, though, to put numbers in variable names later on. So, for example, this is a valid variable name in C#. You can make them as long as you want to. But of course, remember that every time you make long variables like this, you also have to write them down every time. So it's a balance between choosing a representative variable name like lives and not making it too complicated, but don't make it too simple either. If you declare a variable like this, L, with no idea what it is, it might be lives, it might be something completely different, like locks or whatever starts with an L. I'm sure you can think of many examples. Choose useful and clear variable names. Once you've had these variable names, you can assign to them as you like. Let's assign a few more things to these variables. So here you see we do actually two assignments. So after this instruction, lives variable will contain the number 56. When you perform this assignment, that information is thrown away and is replaced by the number 47. Of course, this is an integer, so you can also use negative numbers if you want to. You can also add other kind of operators and do calculations, like so, or multiplying, division. Here you have to watch out, because the outcome of this division should be an integer number. Normally, if you would divide the number 47 by 2, you would end up with 23.5. But since lives is of type integer, it cannot contain these kind of real numbers. They have to be integer. So the real part is simply thrown away. So if you execute this program, and you write out the result of the variable, you'll see that it contains the value 23. Another example of a useful operator is the remainder after division. And this calculates what the remainder is after you divide. In this case, it's going to be 1. If this was an even number, it's going to be 0. If you're dealing with more complicated multiplications and additions like this, you have to take care of the order in which the things are happening. The regular rules of priority apply here, so it means that this part of this expression is calculated before this part is done. So the multiplication happens before addition. So this means that this results in a number of 46 plus 6 equals 52, and not 48 times 3. If you want 48 times 3, you can use parentheses to change the order in which it should happen. Instead of writing only numbers, you can also add variables here. So for example, let's do this. So what you write here is that you take the value that score contains, multiply it by 20, and store it in the lives variable. You can even write the variable name itself on the right hand side. So what happens here is that you take the value of the lives variable, you multiply it by 20, and you store it again in lives. What happens very often with the number of lives, for example, if you pick up a power-up in your game, then you will want to add 1 to the number of lives. And you do that like so. Let's remove this because 56 lives is a bit ridiculous. So what happens here in this instruction is that initially it was 5, we're adding 1 to lives and we store it again, and so lives becomes value 6. There is a shorter notation for this. You can also write it like this, which you can basically read like add 1 to lives. And you can again on the right hand side write here anything you want. If you want to add 45 to lives, you do it like this. Similar abbreviation happens and exists for multiplication. So you can multiply lives by 3 using this, or divide it by 2. When you're just adding 1, like in this case, there is an even shorter instruction to do that, which is called the increment operator, and that looks like this. This instruction says increment lives by 1. What you can also do with variables is make them constant. Suppose that you want your player to have a constant speed of, let's say, 100 miles per hour. You do that by declaring a variable of type int, but you write const in front of it. And const basically tells the compiler that you can't modify the variable anymore afterwards. So if I were to write this, I would get an error because speed is constant. There are other numerical types. We don't only have integers. For example, you also have floats, which are basically a real number. And when you write a float number like this, you normally write an F behind it to indicate that it's a float. There is also a version of the real number which has double the precision of a float value. Because a float value or a real number can of course have many decimals, and the computer has a limited amount of memory, it has to throw away part of the information. If you want double the precision of floats, you can use the type double. As you can see, when we have double the precision, we don't write an F behind it. So the F indicates that we're dealing with float. Now the advantage of float is, though it's less precise, calculations with floats are generally much faster than with double. On the other hand, double has more precision. And then there's even a higher precision type that's called decimal, where you can store even more precise numbers, especially handy for banking. When you declare and initialize a variable, you don't always have to write the type. For example, you can do something like this. In this case, we just say we're going to declare a variable and we're going to call it points. And because we're assigning it a value here, the compiler knows immediately what the value is and what the type is of this variable. It's not allowed to declare a variable with var without assigning it anything, because then the compiler doesn't know what type of memory should be reserved. Next to these numerical types such as int, float, and double, there are many different other types as well. For example, you have a string, which is text. You also have a type called char, which is a single character. There's going to be a separate video about these types because they have some peculiarities that you probably want to learn about. So this concludes the example on variables and types.